Alright, so in order to solve this problem, we will need the conjugate complex zero property, alright? And what is saying, this formula is saying that if I have a complex number, alright, of the form a plus bi as a zero of f of x, then the conjugate, which is called z bar, alright, which is a minus, instead of plus, it would be minus bi. It would be as well as 0 of f of x. So according to this formula, alright, the 4 is not a complex number, we can keep it. However, minus 3 plus 3i, right here, is a 0 already, right? And is a complex number. Therefore, the conjugate of minus 3 plus I, it will be as well as 0. Or the conjugate of this, it can be minus 3, that the real part stay as it is. And the complex part will become minus I. Alright, so we get 3 zeros in here. Okay. Now, according to the factor theorem, if we have a is a 0, right, f of a is a 0, then x minus a will be a factor of the function or the polynomial, right? So the polynomial that we are looking for, f of x, is in fact going to be equals to x minus 4. So x minus the 4, the a is 4, and then times x minus parentheses minus 3 plus I here, that the first complex 0, times x minus the second complex 0, which is minus 3 plus minus I, minus 3 minus I, and this is going to be your polynomial that you are looking for. So this actually was the easy part. The hard part, I think, is to multiply everything together. So what I'm going to start first, I'm going to start multiplying this complex 0 together, right? So first of all, probably I'm going to take the parentheses, the inside parentheses away. So this is going to be x minus 4 times x minus 3 is going to be plus 3 minus I, and then it's going to be x minus 3 going to be plus 3 again, minus I is going to be plus I. Alright, and then I'm going to use the table. So I get already the table. I played the x plus 3 minus I here, so that will be the first term that I'm going to use for the multiplication. And the second term is going to be this one. So I'm going to multiply these two together. After I do the multiplication, I'm going to multiply obviously by x minus 4. So the second one is going to be x here, 3 here, and I in here. Now, whenever I do the multiplication, so those are my term in red, it's going to be x squared. Here it's going to be 3x minus xi. And the second one is going to be 3x. 3 times 3 is 9, 3 times minus I minus 3i, and then multiply everything by I right now, so it's going to be xi, 3i, and minus, alright, I times minus I, that's going to give you plus 1, alright? I times I is going to be minus 1, minus 1 times this minus is going to be plus 1. Alright, so we can notice here that some terms are going to be cancelled. Minus xi plus xi cancel each other. Minus 3i plus 3i cancel each other. And then whenever you do the multiplication, so your f of x will be x minus 4 stays the same. I didn't multiply it yet. However, this part here, I can substitute it by x squared, and then 3x and 3x, that's going to give me plus 6x, and then 9 and 1 is going to give me 10. And then this is a regular multiplication of polynomials. You could use the table if you want to, but it's not necessarily here. So multiply everything by x, it can be x cubed plus 6x plus 10x, 6x squared plus 10x. And then multiply by minus 4 everything, so it's going to be minus 4x squared minus 24x minus 40. Then we want to add this one vertically, so it's going to be your function f of x is going to be equals to x cubed. 6 minus 4 is going to be 2x squared. 10 minus 24 is going to be minus 12x. And then minus 40. And this is it, guys.